Hi, I'm Ms. Lukowski, and I'm going to be teaching data science next year. A little bit of background about the course. This course is meant to provide students with knowledge of data science, a combination of statistics and computer programming, to meaningfully interpret and analyze data. Throughout this course, data analysis and data visualization will be done using the statistical programming language R, which is commonly used by professional researchers. Authentic data sets and real-world questions around dating apps, NFL suspension, betting on the NBA, public health, science experiments, and other things will be explored while building coding skills, thus providing a genuinely professional environment to work in, one that feels like you're in the workplace and not in a classroom. The goals of this course are for students to learn to use data and modeling to answer questions and to critically evaluate information. For students to develop the habits of mind of a data scientist such that they can problem solve flexibly with data in a variety of situations. For students to develop the practical skills needed across the stages of the data science cycle, including data collection, analysis, and communication of results. And finally, most importantly, for students to learn the skills that are future-oriented, not outdated, and tied to the real world so that they're better equipped for their future careers. This course is going to be divided into 6 units. Unit 1 is where data comes from. Unit 2 is exploring variation. Unit 3 and 4 is modeling variation. Unit 5 is evaluating models, and Unit 6 is model comparison. In Unit 1, we're going to talk about where data comes from. This unit is meant to familiarize students with where data comes from, the process of cleaning data before it's ready for analysis, meaning fixing it if there's mistakes, and the basics of R coding. R is the program that we're going to use to code in this class, and it's the program that most researchers in the real world use to code. All the assignments in Unit 1 are built around cleaning data. We'll do an assignment where students will measure their finger lengths and then compare their data with the rest of the class. We'll also be doing an assignment looking at information from dating profiles and another assignment on NFL suspensions. These activities are going to show students how in authentic data collection situations there are often sources of error that data scientists have to figure out. Maybe those errors are related to different types of units used by those who collect information. For example, someone might record data using centimeters and another person inches. Maybe the errors are related to outliers, like an old account on eHarmony for a 100-year-old who is no longer active on the site. Maybe you nixed that information. And maybe those errors are related to misunderstandings. Whatever it is, these differences, which become mistakes, are often not told to practitioners. Instead, data scientists must examine and understand the data set well enough to figure this out. Data scientists are the ones that need to clean the data and fix it so it all makes sense. This necessitates an understanding of variables and values, which is something we will be working on in this class. In Unit 2, we're going to be exploring variation. So after gathering experience with collecting and cleaning data, students are going to begin learning the skills needed to explore variation in a set of variables. And if you don't know what variation is just a way to show how data is dispersed or spread out. So we'll be doing a few assignments in Unit 2, two that I want to talk about. One is a music experiment. The authentic practice of data science starts with a question. And for this assignment, students are going to explore the question, does music help us memorize content better? Not just with their opinions, but by designing and fully conducting an experiment. They're going to be randomly assigning classmates to try and memorize a specific passage with music or without music playing through their headphones. And they must then recall as much as they can from the passage. Students have to go through the process of organizing data collection and deciding what to do with the data they've collected. They then consider other relevant information that they might need to collect. Maybe they need to collect information about gender or previous knowledge, things like that. And then they're going to explore their results while trying to answer the bigger question, does music help? Another thing we're going to be doing in the class is engineering a better gummy bear launcher. So in this study, we're going to integrate science and engineering with data science as students start with a basic popsicle stick and rubber band gummy bear launcher and collect data on the effectiveness of the design. How far do the gummy bears go with this particular design? Students appreciate that there's a lot of variation in their gummy bear launcher's performance, even when nothing has changed about the design. They also have the opportunity to modify their designs, adding more rubber bands or more popsicle sticks, and they collect data to see if their changes made an improvement. Their goal for this assignment is to examine whether their modified designs are truly an improvement with data. In Unit 3, we're going to be talking about modeling variation. Students are going to learn how to fit models, estimate parameters, and interpret estimates. Two assignments that we're going to be doing in this unit are, well, one is betting on basketball. One of the major reasons why we build models in the first place is to make predictions. And in this assignment, students are going to examine different models they can build to make predictions about something about basketball. So maybe how many points an NBA team might score in their next game. And students will build models based on the mean, median, and mode, consider which data will be included in order to estimate the parameters of their model, and depict error from the model. Then they're going to examine the new data to see how their model did against other models based on what actually happens in the real world. Another thing we're going to do is we're going to do some scenarios with unusual measurements. So students are going to find similarities and differences across several scenarios where we employ an unusual or unrefined measurement strategy. So maybe something like guessing the weight of a cow. So just guessing. And these measurements are, even though they may be considered to lack precision, we'll notice something about the mean and how it still balances things out. And we'll talk more about that when you take this class. In Unit 4, we're going to be talking about modeling variation using the complex model. So students are going to learn to distinguish models with both categorical and quantitative explanatory variables. And if you don't know what an explanatory variable is, it's just a factor that's been manipulated in an experiment by a researcher. We're going to be working on several assignments in this unit, and two that I want to talk about. One is going to be the election model. So students are going to be provided with data from U.S. states with a multitude of different variables to explore, like high school graduates, median income, percentage of smokers, percentage of Trump voters in 2016, things like that. And they'll be charged to predict how different states might vote in an upcoming election year. They're going to select and argue for a particular explanatory variable to be included in their model and talk about why they think that variable is going to affect how voters will vote in the future. We're also going to do an assignment trying to replicate Moneyball. So if you haven't seen the movie with Brad Pitt and Jonah Hill, this is a book. There's a book called Moneyball written by Michael Lewis. It follows the story of a team that had little money who wished to figure out what non-obvious variables would predict baseball players' outcomes. So in this activity, students are going to be in the role of a manager of a baseball team, and they're going to think about what are the obvious explanatory variables that every team might be interested in, and then what would be less obvious variables that still do a great job of predicting how many runs a baseball player could get. So they're going to be trying to create a great baseball team based on non-obvious variables. In Unit 5, we're going to be evaluating models. So at this stage in the course, students are going to learn how to model the distribution of estimates. And one of the assignments we're going to be working on is facial prototypes, where students are going to learn or they're going to examine a hypothesis that some names look like they go with certain faces. For example, he looks like a Tim. Students are going to rate photos of different men based on how much they look like Tim, and then decide which of the two they think is most likely to be named Tim. They're going to work in groups and figure out how to combine their collective knowledge to construct sampling distributions of the mean difference, and the proportion based on different theories. Then we're also going to do an assignment around movie rating sites. Do the big movie rating sites largely agree or disagree with which movies are best? Sometimes I know I see on Rotten Tomatoes, it says this movie's a 97%. And then on Metacritic, it's super low. And we're going to hypothesize which ratings will cohere most with each other. And then we're going to construct confidence intervals, which we'll learn about in the class if you don't know what they are, of the relationships between the ratings on these sites by simulating sampling distributions in R, printing them out, and creating posters depicting their confidence intervals. In Unit 6, we're going to be talking about model comparison, and students are going to learn how to use the F ratio, which you'll learn about in the class, to compare multiple groups together. An example of an assignment that we'll be doing in this unit is an ice melting experiment. We're going to decide which one of these substances added to ice makes it melt faster: sugar, salt, sand, or nothing. We're going to conduct an experiment, gather some data, create some models, do stuff with that, and then compare all four. And then there's a bonus unit that I'm going to add to this class that is not included in the curriculum, but one that I think is important, and I'm going to call it How to Adult. So I'm going to talk about things like how to do your taxes, what insurance is, personal finance and budgeting, banking, investments. I'd like to talk about the stock market. I'd like to talk about how to open a credit card, how loans work, and how mortgages work, things like that. So I'd like to add that to this class because I think there'll be enough time for it. And that's it. That's all I have. I know that's all I have, 12-minute long video. But I hope to see you in class. I hope you're as excited about learning things applicable in the real world as I am teaching it.